Now that we have studied basic CFX graphic user interface and got an introduction to CFX as a software, let us go deeper into understanding and using CFX and setting up different simulation problems in it. The first concept in CFX that is to be understood is basically domain. And what is domain conditions, how to define a CFD domain, what are the different inputs that are associated with a CFD domain. So in this particular section we will see all those domain related parameters or inputs. So this lecture is dedicated to domain conditions within CFX. So first we should be clear with the concept of domain. What do we mean by CFD domain? Domains are regions of space in which equations that are being solved for simulation of fluid flow or heat transfer are solved. So this is the basically region in which these equations are solved, and it can be a fluid domain defined by a volume, and it can be a solid domain defined by a different volume, and it can also be a rotating domain or a stationary domain depending upon what sort of inputs we give. But basically it is a volume in which equations are solved. So it needs a mesh. So only the meshed components which are included in domain are included in the simulation. If we don't have mesh, the domain cannot be used for simulation. How do we create domain? We have already practiced this or seen this in a demo as well as earlier lectures. We go to analysis type and insert domain, and when we insert domain, these are the different properties which are associated with a domain. That is basic settings, which is this, under which we define location, domain type, coordinate frame, etc., and fluid model as well as initialization. So a domain can be switched on or off before importing a mesh. You can just name it, but you can switch it off without importing a mesh. And this is especially useful when different domain types are needed to be defined. So we can just define it or make it off as needed. How do we create a domain and what are the inputs to activate a domain? Now, first panel that comes up after defining or naming a domain is basic settings. In that, first we define the location. Location means only assemblies and 3D primitives can be considered, that is volumes. So we have to define a domain and then associate a meshed volume to it. So this is the location for the meshed volume. Now let us see how to create domain, what are the different boundary conditions or inputs needed in order to create domain. So first thing is the general options panel for any domain, which is under basic settings. So this is the panel whenever you create any domain, whether it's a default domain or a domain created by the user. And in that, the first tab is basically basic settings. So in that we have the first input as location, in which we can only give volumes that are present in the mesh. It can be assemblies of volume or primitive volumes. The next is domain type, which is given here. In this we can give what type of domain it is. We can give whether it is a fluid domain, a solid domain, or a porous domain. The next input is coordinate frame, in which we select the coordinate frame from which all domain inputs will be referenced. After that, we select whether we want to define fluids or particle within that particular volume, which means in that domain whether fluid is present or particles are present, and which type is defined after that. So once we select whether it is a solid domain or a fluid domain or a particulate domain, then we select the fluid type. So in that we can select different fluids within the database of solids, gases and liquids, which can be done here in this particular drop down box. After that we select morphology options, which means whether we want to define it as a continuous fluid or a dispersed fluid, a particle fluid, whether we want to model multi-phase in it. All these morphology options are selected here in case we want to select multi-phase flow modeling. So that is the basic settings within the domain. Now we will see the second tab, which is domain models. In the domain models, the first settings is reference pressure, which is the reference pressure which is used for various calculations, whether we want to calculate gauge pressure or any other pressure calculations. Also then after that we want to select buoyancy, whether we want to consider buoyancy effects or not, and if we want to consider what is the gravitational acceleration and its direction, and also the reference density for buoyancy calculations that we have to give here. After that the input is basically domain motion, which is given here. In that we can define whether our CFD domain or volume is rotating or stationary, and if it is rotating, what sort of angular velocity it has. So that is basically for different fluid models. Then we go into heat transfer models, and within heat transfer models we have an option whether we don't want to model heat transfer, or whether it is an isothermal model, or whether it is a thermal energy or total energy model, whether in which we actually model temperature distribution. Also, after that we select the turbulence model if the flow is turbulent. In that we select many models that are available, starting with K epsilon and ranging to complex models like RSM model. And also we select turbulent wall functions associated with models, which depends on what type of turbulent models you select. After that, after selecting turbulence model here, the next is basically whether we want to model reaction or combustion. That selection is done here, and it is available only if a variable composition mixture is selected as a domain fluid. So that we have to be careful. In the basic setting itself, we have to select variable composition mixture as the domain fluid. After that we have thermal radiation model, which is basically selected here in the thermal radiation drop down box. In that we can select several models if a heat transfer model is selected, and after that we can select additional variable details as required if we want to solve any additional variables along with the basic heat transfer, radiation and reaction modeling. So that we can select here. So once that is done, let us look into details of heat transfer model. If within that heat transfer model we select none as the option, then energy transfer equation is not solved. If we select isothermal as an option, then fluid properties are temperature dependent, but energy transfer equation is not solved. So that sort of thing is done. Also, if we select thermal energy as an option, then energy transfer equation is solved, excluding viscous work term or viscous dissipation term. And then if we select total energy as an option, this model solves the transport of enthalpy including kinetic energy effect. It should be used for gas flows where Mach number exceeds 0.2, and high speed liquid flows where viscous heating or effects arising in boundary layer where kinetic energy becomes significant. So we use total energy in those sort of situations. Otherwise we use thermal energy model. So these are the four options that we have, that is none, isothermal, thermal energy and total energy for the heat transfer model selection. After that, if we have model solid instead of modeling it as fluid, in that also we have various options. The solid domain representing solid regions in which the equation of heat is solved because there is no flow. So that is referred to as conjugate heat transfer. Then solid domain allows for a different set of models in which we have the heat transfer model as thermal energy, and the radiation model can be selected as none or Monte Carlo. So this is for the solid domain where we don't have much option, but only the option is thermal energy or radiation model. So that is the only option that we have. Since we have now seen how to create domains and how to define various inputs related to domain, the next important thing is to actually associate or to fix a particular material for fluid flow through that domain, or for solid modeling through that domain. So how do we basically fix or select a material which can be air, water or any such material that is flowing or that is part of the solid? So for that we basically have to select fluids to be solved in the domain, which can be done by going to fluids and particle definition, and from the drop down whatever is available by default we can select those. Now if our problem does not involve any of the default fluids, we can also import from material library. This can be done by basically just clicking on this particular icon, and after that it opens up a list of material library from which we can select any material that is there in CFX. There is a huge library of materials. So additional materials can be available by clicking on these ellipses, and this is where they actually can select library data to be imported into the materials. So we have different types of materials that can be selected through library data of CFX, and that can be imported into the current modeling environment, and that can be selected under this after importing. So this is the way we select different materials. Other than that, we can also create material by right clicking and editing by saying material in the outline tree. So if we want to create a material, we just right click here, insert material. After that we can create our own material, that is a customized material definition in which we can select the current choices, and also material properties can be defined by the user, and we can define the variation of properties as well, and create customized new materials and give them name and use them in the analysis. Now let us say we want to model mixture of gases or species or chemical species. How to do that? ANSYS CFX has the capability to model fluid mixtures consisting of an arbitrary number of separate physical component or species. For that what we have to do is basically we have to say variable composition mixture in the basic settings of materials, which is in the drop down list. And after that we can select combination of chemical species or combination of material and define a mixture of two or more different materials. So this is the way we create multiple or multi-species flow. So that is how we press Ctrl and select different materials and prepare a mixture of that by selecting variable composition mixture.